Hi, everyone. My name is Jackson Roberts. I've been involved with Lisk for about 2 years, and I've really been enjoying using the SDK lately. It's definitely my favorite way to develop blockchain applications, and I've worked with quite a few of them. And I'm here to present to you guys a project I've been working on called Moracle, the highly reliable blockchain app compatible API for anything. So this is an API request, and more accurately, it's a hypothetical API request. And so here, we're getting some data from hypothetical API, cryptopriceapi.com. We're parsing the result, and we're getting the price of Lisk in euros stored in our variable. And so this sort of query is really important. APIs sort of form the backbone of modern interconnected applications, and they're really important. But blockchain apps can't access them. And for this reason, blockchain apps are data starved. And this is for a pretty good reason. And so at the moment, there are ways for blockchain applications to get data through something known as a blockchain oracle. Effectively, it's a service that sits in the middle, and it requests data on behalf of the blockchain application, and it embeds it into the blockchain, and then the application is able to access it. But this is sort of just a bandaged solution because it's connecting two sort of fundamentally incompatible systems. We have decentralized, trustless, autonomous blockchain applications that, for all intents and purposes, are unstoppable. And then we have these centralized, trust-requiring internet APIs. And so even if we have some sort of adapter, some sort of intermediate layer to connect them, we're still connecting two systems that were never really meant to be together. And if the API goes down, your application will break, even if you're using an Oracle service. And this is because the internet is inherently unreliable. APIs can serve incorrect information, they can go down, they can change format, and any one of these things will break your application. And so if we look back at this example, we can immediately see the problem. There is a single point of failure. There's this cryptopriceapi.com. And if that goes down, our application will cease to function. And here's an example in Provable/Oracleize, and it's one of the most popular solutions on the market right now for connecting blockchain applications, particularly those on Ethereum, to the internet. It's a little bit more complicated. It has a little bit more cruft around it. But the problem here is the exact same. We're still accessing a single API, a single point of failure. And this is just due to a design flaw in traditional oracles. They really only have two goals that they're trying to meet. They want to ensure that the data for requests that were made in the past are always available. And this is so that when a blockchain application has to resync from scratch, it has the information that existed in the context of these previous transactions to do so. And it also needs to ensure that all nodes on the network get the same answer to a request. And this is because decentralized applications are effectively just code running on multiple computers, and they all must reach the same result to arrive at consensus. Moracle adds a third goal. To ensure that the data source being requested is always available, not just requests made in the past. And this is a new way of approaching this problem that helps the data sources that power decentralized blockchain applications to be as reliable as those blockchain applications themselves. And so here's what a Moracle request looks like. As you can see, there's no URL, there's nothing, there's just a GraphQL query. And so this was a query language that was invented by Facebook a couple years ago. And it's a way of sort of querying more abstractly for resources rather than for endpoints. And it also lets you control exactly what format you get your data back in. So here, for example, we queried the get cryptocurrency price resolver. We pass it in the Lisk ticker, and we get the currency pair euro. And so since it's GraphQL, if we need more currency pairs, we can just add those to our query. So if we want to get the US dollar as well as the Chinese yuan, we can do that. And so this works because Moracle provides a global GraphQL schema. And it lets anyone contribute to how these data sources function and operate. And so, for example, this get cryptocurrency price resolver could be implemented in a way that it loops through 20 crypto exchanges. It gets the exchange rates from all of them, and then it merges and averages those results and returns them to the data requester. And so if one of those exchanges goes down, your application still works. If one of those exchanges is delivering incorrect data, your application still works. While both of those situations with existing solutions would break your application. And so the advantage of this is multiple-fold. We've replaced these single API endpoints with more generalized requests for information. We've replaced a single data source with multiple data sources. We can perform network-side statistical analysis for rapidly changing information such as financial markets, where we can get network-wide averages and network-wide statistical information such as standard deviation. And since every resolver is just a piece of JavaScript that gets sandboxed and run across the network, we can also perform arbitrary computation. And so it's one interface that you can use to query any data source. It's all just GraphQL, and if you need some exchange rates and maybe even some sports results, if you're making a decentralized betting app, or weather information, flight information, it doesn't matter. You can access it all through a single data source. But despite all of this flexibility and customization, it remains really fast. With our current proof of concept, it returns results a lot faster than existing Oracle solutions. But it's important to keep in perspective that we're not really competing directly with these existing solutions. We provide a completely different approach to solving the problem. These are, on the left, are just bandage solutions. They connect centralized, trust-requiring traditional APIs to blockchain applications, which ultimately ends in problems. We provide more generalized repositories for data that can be queried and that anyone can contribute and add more information to. We have an inclusive economic scheme where anyone who has access to an API or a data source can run a Moracle node and service resolvers and get paid in our native token for it. And given that fixed costs are often a reality in this, if, for example, you're distributing information that comes from an API that charges a fixed amount per request, our fees can be fiat pegged. So if you need to be paid at least 2 cents to service a certain query, you can set that up. And we actually use our own technology to implement this, since we can get a network agreed upon exchange rate for any cryptocurrency. We can use that to implement these dynamic fees. We're also planning on developing Moracle for enterprise. And so basically, lots of companies have APIs. And lots of them are aging, and lots of them have problems. And so we're offering basically a drop-in solution that can take these APIs that might be an old SOAP interface, some sort of XML RPC, or REST, and replace them with a modern GraphQL API, as well as providing caching, and just as a bonus, their applications will work with blockchain. And given that JavaScript is the fastest growing enterprise language, and it's about to be the most popular enterprise language, we anticipate that lots of companies are going to be interested in using Lisk to develop applications that help meet their business logic needs. And so we plan on providing a comprehensive solution for connecting their existing legacy systems to their new blockchain systems. And that is Moracle, the universal data adapter for Lisk. We hope to build a developer tool that is a joy to use and helps people build ultra-reliable blockchain apps that are provided with ultra-reliable data to match. Thank you very much.